Alright, tonight begins our focus on the double angle formulas. So a double angle refers to when you have something like the sine of 2x, because you are doubling the value of your angle x. So to help us find the formulas, we're going to think of 2x as being broken up into x plus x, and we're going to use our sum formula, so our adding formula for sine, in order to help us find our new formula for the double angles. So this is going to be the sine of your first angle times the cosine of your second angle plus the cosine of your first angle times the sine of your second angle. Well, since these angles are all x's, because we have x plus x instead of our usual a plus b, I have sine times cosine and sine times cosine, which equals 2 sine times cosines. There's your formula. Thinking about the tangent of x plus x, I'm going to use the sum formula and say this is going to be the tangent of my first angle plus the tangent of my second angle over 1 minus the tangent of my first angle times the tangent of my second angle. Again, that's from the sum formula for tangent. All of that is going to simplify into 2 tangent of x over 1 minus tangent squared of x. And there's your formula. Last one then is going to be cosine of x plus x. So again, I'm going to use my sum formula and say this is going to be cosine of the first times cosine of the second minus sine of the first times sine of the second. Well, this is where I get some different options. So I get cosine squared of x minus sine squared of x. Here's one formula. But we know from Pythagoras and his identities, try to extend the page there, I could replace cosine squared with 1 minus sine squared of x, and I still have this minus sine squared of x. So when all is said and done, that's 1 minus 2 sine squared of x. You've seen this before in verifying and simplifying identities. Okay? Likewise, I could think about this original one that I found and replace the sine squared. So I'm going to leave cosine squared where it is. This time I'm going to change the sine squared into 1 minus cosine squared. Distributing in, I'm going to get cosine squared minus 1 plus cosine squared. So I now have 2 cosine squareds minus 1. So the double angle for cosine has 1, 2, 3 different versions, but they're all based off of using our sum formulas. Alright, here they are in a nice summary. Again, notice cosine has 3 different versions. I'm also going to say that a little shortcut for tangent of 2 theta could also be to find the sine of 2 theta and divide it by the cosine of 2 theta. Alright, so solve between 0 and 2 pi, sine of 2x plus cosine of x. Usually our technique with solving equations is to get everything in terms of one trig function, move things to the other side, maybe divide by a cosine. But here I've got this 2x combined with something with just x. So I'm going to take sine of 2x and using the new identities that I just came up with, I'm going to say that's the same thing as 2 sine x times cosine x. Plus I've got another cosine of x, all equal to 0. These two things are going to have a cosine of x in common, so you could factor that out. And you'd be left with 2 sine of x plus 1 equal to 0. Well, now I've got 2 things that multiply to 0, which means either that first thing has to be 0 or that second thing has to be 0. Where is cosine equal to 0 between 0 and 2 pi? That's going to be at pi over 2 and 3 pi over 2. This one's going to require a little more solving. I'm going to say the sine of x is equal to negative a half. Sine is negative in quadrants 3 and 4. Has a 1/2 value at the 30-degree reference angles. So we're going to say it's going to be 7 pi over 6 and 11 pi over 6. Those are your final answers. Alright, this one again, we've got some things combined with 2 A's and just A's. So a good way to start would be to get rid of this sign of 2A by writing 2 sine of A times cosine of A. I still have a sine of A, so all equal to cosine of A. I don't like that mix of double angles and single angles combined. Sine of A times sine of A is going to be sine squared. I'm going to go ahead and subtract this cosine of A to the other side. I don't want to divide by cosine because you could end up losing a root. That's like dividing both sides by x. You don't want to divide out by something that's a variable. Instead, you want to get everything on one side and factor out what they have in common. So these both have a cosine of A in common. Left with 2 sine squared A minus 1 is equal to 0. Two things multiplying to 0. Cosine of A will be 0, or 2 sine squared of A minus 1 is equal to 0. Just like on the last one, cosine will be 0 on your unit circle at pi over 2, and 3 pi over 2. This one, I'm going to say sine squared of A is equal to a half. When you take a square root, you get a plus and minus square root of 1/2. Well, the square root of 1/2 is the same thing as the square root of 1 over the square root of 2, which is really 1 over root 2. Do some rationalizing, and you get root 2 over 2 with a plus or minus. So really, this square root of 1/2, I'm looking for where is the sine of A equal to plus or minus root 2 over 2. And the answers there are going to be four different angles. We're going to say pi over 4, 3 pi over 4, there's our positive versions, and 5 pi over 4, 7 pi over 4 give us our negative versions. Find the sine of 2 theta, or 2 alpha, sorry, cosine of 2 alpha and tangent of 2 alpha, knowing that cosine of alpha is negative 2/3, and pi over 2 is less than alpha is less than pi. So really what this information in purple is telling us is our angle alpha is somewhere in between pi over 2 and pi, and it has a cosine value of negative 2/3. Doing some Pythagorean theorem, I can find that my missing side here is going to be the square root of 5. So I could get 9 equals y squared plus 4. Y would equal plus or minus root 5, but since I'm in the second quadrant, I would want to go negative 2 up root 5. So I've got my lovely angle alpha drawn here. Now I'm going to use the formulas from our first slide. So I'm going to start with sine of 2 theta, just because it's listed first. I know that the sine of 2, I keep saying theta, 2 alpha is going to be equal to 2 times the sine of alpha times the cosine of alpha. So using what I have in this triangle, that's going to be 2 times root 5 over root 5 over 3, jump to a tangent there for some reason, times the cosine, which is negative 2/3. So 2 times negative 2 is negative 4 root 5. 3 times 3 is 9. That is the sine of twice this angle. Now if you think about this being our alpha, right, and then we're using this reference triangle, if I were to take this angle and double it, it would make sense that my sine value would end up being negative. Next I'm going to do the work to go through and find the cosine of 2 alpha. So cosine of 2 alpha leaves me with a lot of different options. I had those 3 different equations I could have used. I'm going to choose just to use the first one, which is, or sorry, the last one, which is 2 cosine squared of alpha minus 1. So that's going to be 2, the cosine here of alpha is negative 2/3 squared minus 1. So this is going to be, oops, don't know what's going on there. 2 times a positive 4/9 minus 1, which gives me 8/9 minus 1 whole, which will all equal negative 1/9. Alright, again, if you think about this being alpha, 2 alpha would put me somewhere in the third quadrant, so my cosine value should come out negative. Last one is going to be the tangent of 2 alpha. For this one, I'm going to use the official formula, which is 2 tangent of theta, so 2 times root 5 over negative 2, all divided by 1 minus root 5 over negative 2 squared. So on the top, I'm going to get negative root 5, because our 2's are going to cancel. On the bottom, I'm going to get 1 minus 5/4. So keeping going with my fractions, negative root 5 over negative 1/4. Multiplied by a reciprocal, I'll get negative root 5 times negative 4 over 1, which ends up being a positive 4 root 5. If my double angle was this one and a double it, ending in the third quadrant, again, it makes sense that tangent ends up being positive. So just a way to justify your answers a little bit. Another way to do tangent is to say that tangent of 2 alpha is equal to the sine of 2 alpha divided by the cosine of 2 alpha. Your 9's are going to cancel. Negative 1 and negative 4 are going to make your positive 4 root 5 if you go through and multiply by a reciprocal. And you're good. Alright, in conclusion, your double angle identities can be used to help solve your trig equations. So if you have some mixture of 2 theta and theta, use some double angle identities. Also, you can use them to evaluate trig functions, like the last example. Draw out your triangle in whatever quadrant it's assigned to, and then you can use them to find the other trig functions.